There appears to be a favorable environment in place for severe thunderstorms this evening, but there are still some questions as to how extensive the threat will be. In this video, I'm going to talk about how that capping inversion that we had yesterday is also going to influence severe weather today, and then also the hazards we could have with some of the storms that develop later on this evening. Hello everybody, it is 8:57 a.m. and it is August 24th. Welcome to another update from Great Lakes Weather. Hopefully everybody is doing well today. We have severe weather on the way possibly for quite a bit of lower Michigan this evening. Parts of northern Indiana and northwestern Ohio are going to be included in that as well. And the potential is there for significant damaging winds. Some hail and some isolated tornadoes also appear possible. And this is likely going to be occurring after 7 p.m. tonight across much of the region. Now, some models are saying that there is going to be storms. Some models are saying there's not even going to be any storms. This is a similar pattern we had last night. More models, though, are now saying that there could be some storms with this setup. So the SPC is a little bit more confident on it, and let's look at that right now. Before we get to that, though, I want to talk about what is happening as of this current time. You do see this band of strong thunderstorms that was ongoing over much of the day yesterday across parts of Ohio that is now starting to diminish and dwindle out. Now, a lot of these storms prompted actually some flash flood warnings across eastern Ohio and eastern Detroit. 4 to 6 inches of rain fell in some spots, leading to some street flooding, so definitely causing some problems. Hopefully that's starting to dwindle away at this point, which the storms are starting to die out. But one thing that we want to point out with this as it starts to dwindle as well is that we have you may notice that there's an outflow boundary that is coming out of these storms here. You see this outflow that is starting to surge out away from these storms? That's rain-cooled air, actually, that is making its way out towards the west, okay? And that rain-cooled air is actually causing some disturbance in the atmosphere that is enabling some new showers to develop. These storms do not have any lightning. It's just regular rain showers, but there is a little bit of wind within these cells that are developing here as well. I expect these to die out pretty soon. And the one thing about this outflow boundary is that it is taking away a lot of that instability that is out here in the atmosphere as well. But I expect a resurgence of the warm air mass later on today as we get to daytime heating, and the instability start to really ramp up once again in this area. Okay, this outflow boundary has gone a little bit farther than expected. It didn't die out as quickly as some models predicted, but I still think that this warm air mass is really going to surge up into this area, bringing those hot, humid temperatures back for a day before the cold front that is going to be bringing our strong thunderstorms later this evening begins to move into the area. So that's what's currently going on out in the region. We did have a few severe thunderstorm warnings. We had one just south of Dayton in this area. We had quite a few. We actually had a tornado warning, I believe, in parts of Cleveland. Had a couple severe thunderstorm warnings in the Detroit region, and then those flash flood warnings were kind of scattered all around this area as well. So definitely some storms that caused some impacts across the region. Again, yesterday's threat was very much in question as to how much we could have seen. We did not see as much severe weather, but we did see a lot of heavy rain associated with flash flooding, okay? And that's something that was still kind of at question. This is a little bit at question with this setup too, but we'll have to just see what comes around with these later models that will start to predict exactly what's going on. So let's get to exactly what the SPC is saying at this point. Slight risk for severe thunderstorms. Again, this is the possibility of the SPC's setups do really show just the potential for an outbreak setup. Slight risk really just means there's a slight chance that this could be a widespread severe weather outbreak rather than the severity of the storm. Keep that in mind. There is going to be a lot of instability in the air if these storms do fire, okay? Instability values of over 5,000 even in some spots. That's pretty extreme given this hot and humid air mass that we're going to be in. But slight risk does exist. Let's look at the specific threats here. You have a tornado threat, okay, that does exist. And I'm wondering if I could zoom in on a more local. I can't do that with this graphic. But you can see it includes southeast or southern lower Michigan, southeast lower Michigan for the tornado potential. Tornado potential, again, is there, but I don't think it's going to be as threatening as the wind potential that exists. Northern Ohio is included in this again as well. Detroit, places that saw that heavy rain previously, also included in that as well. You also have a hail threat. The hail threat's actually focused much around lower Michigan at this point, so you can see that shown there. Hail potential with these initial cells that will fire across this region. Kind of a broad range of it because, again, storms could fire up here, storms could fire down here. It really does depend on what that cap does later on this afternoon and evening. And last night was a pretty strong cap. Pretty strong capping inversion kind of restricted a lot of the thunderstorm development that we were expecting much across this area. But I mean, there was so much thunderstorm development in this region here. But a few storms popped up here and kind of followed along with these ones, sort of making that train of heavy rain across that region. So hopefully the rain is a lot less. But here's where the more concerning setup occurs. Okay, so you have this hatched area. What this hatched area says is that there's the potential for significant damaging wind gusts greater than 75 miles per hour. Okay, why is that? Well, it's because we have a high amount of instability in the atmosphere, and there is going to be a little bit of a favorable kinematic environment for this setup as well. But that hatched area is a place where you can see significant damaging winds. Okay, that includes the Lake Erie shoreline along the northern edge. It includes eastern Michigan, western Michigan, pretty much anywhere south of I-96 is going to be dealing with that hatched area, and then areas such as Flint, Owasso, those regions looking at that hatched area. How late is this going to be? Well, the timing is still a lot at question. It could be any time after 4 p.m. really is kind of what the expectation is. Likely going to be more along the lines of after 6 p.m. and maybe just prior to sunset, 8 p.m. we'll see those storms begin to develop, packing damaging winds potential, more effectively damaging wind potential, hail, and maybe an isolated tornado. Again, there's still some questions with the capping inversion that's going to be in place in the atmosphere. We're going to look at that on the weather models as well. So I will also explain once again what a capping inversion is for those of you that didn't see my video yesterday. All right, so let's back it up. We're going to look at all the models individually, or at least the higher resolution models right now. Now, first of all, I want to see if I can find a capping inversion graphic. So this is 2 p.m. Okay, Thursday, August 24th, 2 p.m. One thing that we look for in the atmosphere that can inhibit thunderstorm development is something that's called a capping inversion. So what a capping inversion is, if I can pull up a model that shows it. So far there's not really a model that does show that particular capping inversion, but what a capping inversion is basically, if you look at this sounding, okay, what you see here is what is called a skew T chart. Okay, this is a skew T chart. It actually gives us kind of a dissection of the different temperature, dew point, different factors causing a storm environment in different parts of the atmosphere. You look over here, you have 0 kilometers, 1 kilometer, 2 kilometer, going up to 5, 9, 12, 15 kilometers, and so on and so forth. Okay, as we look at these different changes in temperature and dew point, one thing we can look for that might inhibit thunderstorm development is something called a cap. So what a cap is when the temperature, which is this red line here, exceeds that of the lapse rate, which is the dotted line here. Well, what is the lapse rate? Well, the lapse rate is actually really the best way to describe it is the amount a parcel of air is expected to cool with height. Okay, so as it increases every kilometer, it's expected to cool a certain amount. Okay, so the wet adiabatic rate and the dry adiabatic rate, we can talk about that a little bit later. But those rates change based on the moisture content that does exist in the atmosphere. And the expectation is that there will be the potential for some cooler, drier air to make its way into from the north, associated with a trough on a cold front that's going to be moving in. And that could steepen our lapse rates and weaken that cap a little bit that is going to be in the atmosphere. So that's what we're looking at. When you look at it in a skew T chart, okay, the temperature will go past the dashed line to the right, and that is something that will cause a capping inversion, okay, because the air above is warmer than it is at the surface, or it's warmer than what we would expect it to be at that height, inhibiting thunderstorm development. When we look at this number here, convective inhibition, okay, you can see on this model it's really low. Okay, the HRR is actually predicting a very low cap, not much, or low convective inhibition, so not too much of a cap. Okay, convective inhibition is what a capping inversion can cause convective inhibition. So that's something we're going to be looking at very carefully as this threat comes into play, because the environment's great. I mean, the environment's right there, but the capping inversion could inhibit strong thunderstorms from developing later on this evening. Okay, last night we had a strong cap. There's hints that the cap will likely weaken later on this evening, which is why this threat is a bit more robust, and it's one I'm probably going to chase around 7 p.m. this evening. All right, so let's get a look at the models here. This is the latest, or actually it's not the latest model from Pivotal Weather, and we won't be able to see the latest model just yet. We may come back to that. I'll show you what the 11Z model looks like. Okay, so as we get to 7 p.m., okay, HRRR is actually playing this threat much farther to the north. Okay, NAM is playing it farther to the south. Okay, which model's right? Well, that's the question. That's why the timing is kind of variable. Okay, 7 p.m. As we get to 7 p.m., you do see storms firing up by Mount Pleasant and storms firing west of Grand Rapids over the lake. That is what the HRRR projects. Convective allowing models are actually showing a nice line beginning to develop, and I'll show you a cam in just a minute. But you notice that some of these storms have the potential to take off very quickly. Again, it's an explosive environment for severe thunderstorms. Mount Pleasant, you do see your updraft velocity exceeds 75 meters squared. All right, so meters per second. And as you get that updraft velocity increase, the potential for a strong supercell will develop, potential for producing a possible tornado. There's marginal tornado potential being shown. Storm relative velocity gets up to 230, okay, and your shear is getting close to 50 in some spots, which, again, higher wind shear, higher chance of a supercell, higher chance of a tornado. Damaging winds, though, look to be the primary threat with this, but these initial supercells will pack low cloud bases, okay. Those low cloud bases will influence the potential for a stronger storm. All right. So you see that these storms will explode pretty quickly as that cap continues to weaken during the evening. 9 p.m. we have storms just north of Lansing, some pretty powerful storms just north of Lansing that are occurring. Tornado potential looking to be much higher with this. Look at the supercell composite value, 21.5. That is a very large number. Okay, convective inhibition still looking pretty low at this point. And in fact, the SKU-T chart actually indicates that there won't really be much of a cap at all, according to the HRRR model. Progressing it forward, you do see that these storms just continue. One thing that the HRRR is different on than the NAM, which we'll look at in a second, is that these storms are going to be farther to the east. Now, the HRRR has been more accurate about these setups over the past couple of days, so this might be a more believable setup. Again, we'll have to see how the models change over the next couple of hours, but you do see that Lansing, Flint, seeing some pretty significant severe thunderstorm activity possibly with these storms moving in. Likely to have some significant damaging winds associated with that. But as we continue forward, you see that those storms continue to progress and begin to dissipate after about midnight, move out of the area. Let's take a look at Ohio real quick, because Ohio is also included in this threat on the northern side. So let's take a look at Ohio real fast. You do see that those storms will continue into northeastern Ohio at about 1 a.m. according to the HRRR model. Could packing possibly significant damaging wind gusts. Okay, the environment is going to be explosive, especially over southern lower Michigan. So that's going to be the place to really watch for severe weather activity during this evening and later on into the night hours. So back to a Michigan view. We're going to compare it to the NAM now. The NAM plays it farther west. Okay, so let's have a look at that on this upcoming model. Now, the NAM is showing that outflow from that initial storm, those initial storms that fired across Detroit that are dissipating, those will likely be completely dissipated and gone by 11 a.m., moving completely out of the area, and then what we'll see is likely that warm air begin to filter back into the area, hot and humid conditions likely to return. And then by 7 p.m., again, you see those storms beginning to fire across west of Mount Pleasant, west of Grand Rapids, just like the HRRR does project. But it does take a more takes a setup that looks more like a northwest southeast setup, and it also is going to be in parts of western Michigan as well. This is 8 p.m. Okay, you get a sounding of those storms, tornado potential, and also supercell composite values remain relatively high. You do have CAPE values of over 4,000, which is a very significant number. You do have directional and speed shear in the atmosphere. You do notice that winds are out of the southwest at the surface, and then in the upper levels you have strong winds out of the northwest. Okay, so that is definitely going to lead to some directional shear in the atmosphere. And you do see a line forming pretty much along this area here, Kalamazoo to Lansing, along the I-69 corridor, I-94 corridor. My real target area today is going to be pretty much Kalamazoo, Calhoun, Berry, St. Joe counties, and then we'll also possibly go up into Ionia County if the storms do fire like the HRRR says, which will be farther to the east. I'm probably going to stay out a little bit later tonight, tracking these storms with the strong lightning that is going to be expected with the higher heat values as well. So, severe weather potential is definitely present. You can see it kind of organizes the same way on the eastern side of the state, according to those, according to what the HRRR also said, and then those storms will move through down into Ohio again around midnight, 1 a.m. and could pack some damaging winds. So, definitely something to keep in mind there. So, convective inhibition, okay, again, we're going to compare the models regarding the convective inhibition, the potential for that cap that exists in the atmosphere. Oops, wrong button. All right, so let's compare the models here. So you have the Euro model, okay, shows a weakened cap across southeastern Michigan. HRRR actually agrees with this assessment, okay? So, in fact, we have the most recent model of the HRRR. The HRRR actually shows a much weaker cap than the previous one did. So the capping inversion appears to be not really as present this evening, going to be weaker. Some models show a pretty strong cap. For example, you have the HRW showing a pretty strong cap over northern Michigan, but a weakened cap over southeastern lower Michigan. It's actually playing that potential for storm development farther to the south, okay? And then you have your NAM model. A lot of the models are really agreeing that southeast lower Michigan is going to have a weakened cap, okay? And that weakened capping inversion is what is going to enable those storms to take off in the explosive environment that we have, okay? Let's freeze frame it back onto the HRRR and get a look at some of the other dynamics that are going to be in place here. 500 millibar height, again, you do have upper level support. The strongest winds are staying farther to the north. And then you have mid-level support also present with these storms that will be developing as well. And you'll also have some light lower level support also present with these storms as well, capable of those isolated tornado potential with that as well. So, again, there is going to be an explosive environment in place. Cape values getting close to 4,000 across much of southern Michigan, northern Ohio. The Cape values are also high down here in Indiana, but that doesn't necessarily mean the storms will form there. Again, you don't really have much of a lifting mechanism, and the capping inversion is likely going to stay in place in Indiana. Cloud bases, again, seeming a little more elevated. Again, once those storms begin to develop, though, that could possibly change. You might see a lower cloud base, generalized cloud base setup in the region. The shear, again, if we go to more of a 8 p.m. time frame, you do see that there is some embedded wind shear in these storms, but the shear is relatively low out ahead of it. It's because you've got mainly your cold front that's causing that lift in the atmosphere. So that's really why you see storm multiplicity really take off associated with that cold front that's going to be moving through. So, big thing here is these storms are heavily dependent on the capping inversion that we're going to have, okay? If there's no cap, these storms will take off. If there is a cap, these storms will not, okay? More likely than not, though, it does appear that there will at least be some storms across eastern Michigan, northern Ohio, possibly across western Michigan as well. So that is the big question we're going to be looking at. And I will be storm chasing around 7 o'clock. I'm just going to try to burn and catch up to these storms as I can. Have an important meeting I got to be at around 6, so I can't really go up and get on those storms as I'd like to. But make sure to subscribe and stay updated. I'm going to be getting on these storms. Probably will go a little bit into the night as well as that lightning begins to really take off with these storms too. So southern lower Michigan, definitely want to be watching the weather this evening, especially if you're in the eastern side. Potential for 70 mile per hour wind gusts is present and could possibly happen. So just stay tuned for that. Stay safe out there, everybody. Thanks for watching, and I'll see you all later.